Math 107, Lesson 19, Demo. Does every function have an inverse function, and how can we tell? To answer this question, we're going to examine two functions, f of x equals x plus 1, and g of x is x minus 1 squared. So we're going to start with f of x equals x plus 1. We're going to find 4 points on the graph. So if you plug a -2 into f of x, -2 plus 1 is -1, -1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 2. So the coordinates of these points would be -2, -1, -1, 0, 0, 1, and 1, 2. If you reverse the components of each point, so make your x the y and the y the x, so this -2 becomes the y, this -1 becomes the x. We're just switching the roles here. There we go. So for the function f of x equals x plus 1, different inputs produce different outputs. And so my inverse is a function. Right? So when I swap the components, the inverse is a function. So f of x equals x plus 1 is 1 to 1. All right, let's look at another example. G of x equals x minus 1 squared. Plug a few points in here. So -2 minus 1 is -3, and when you square that, you get 9. -1 minus 1 is -2, and when you square that, you get 4. And 4 minus 1 is 3, and when you square that, you get 9. And 3 minus 1 is 2, and when you square that, you get 4. So those points are -2, 9, -1, 4, 4, 9, and 3, 4. So this is a function. This is g of x is a function because there are no x's that give two different y's. But when you reverse the components of each point, now I have 9, -2, 4, -1, 9, 4, and 4, 3. So I do have x coordinates that produce different y coordinates. So my inverse is not a function. The inverse of g is not a function, which means that g is not 1 to 1. So when you swap the inputs and outputs of our functions f and g, we noted that the inverse of the linear function f is a function, but the inverse of the quadratic, g, was not a function. Can we look at the graph of a function and tell if it has an inverse? So draw a horizontal line, y equals 4 on the graph to the left. So that would be right here. How many times does the horizontal line intersect the graph of g? Once, right here. If any horizontal line, such as the one we just drew, intersects a graph at 2 or more points, then the graph of the function will not have an inverse function. We refer to this visual test as the horizontal line test. So I could do another one down here, see that this intersects in 2 points, and we say that g does not have an inverse function. G is not 1 to 1. All right, let's look at how to find the inverse of a function algebraically, find a formula for the inverse of a function. If a function is defined by an equation, we can obtain the equation for f inverse by interchanging the role of x and y, because that's what inverses do. They swap the role of x and y. Your textbook refers to this procedure as switch and solve strategy. So we're just going to list it out and do an example. So I've got f of x is 1/2 times 4 minus 5x plus 1. First, we should verify that this function is 1 to 1, that it passes the horizontal line test. We can look at a graph. That's usually the easiest way to verify that something is 1 to 1. All right, so I have graphed the equation. It simplifies to y equals -2.5x plus 3, which is just a line. You can see it definitely passes the horizontal line test. This is the original way that the formula was written, 1/2 times 4 minus 5x plus 1. Just a line, so it passes the horizontal line test. All right, my next step is to replace f of x with y in the equation for f of x. So I have y equals 1/2 times 4 minus 5x plus 1. Instead of f of x, write a y. Then interchange x and y. That means everywhere you see a y, make it an x. Everywhere you see an x, make it a y. So this becomes x equals 1/2 times 4 minus 5y plus 1. And then you solve for y. So now we want to get the y by itself. So I'm going to distribute my 1/2. So I have x equals 2 minus 2.5y plus 1. Combine my like terms, my 2 and my plus 1 make a 3. Negative 2.5y plus 3. Subtract 3 from both sides. And then divide both sides by negative 2.5. So I have y equals x minus 3 over negative 2.5. Finally, replace y with f inverse of x. So this is just the notation to indicate that the formula I just found is the inverse of the formula for f. And then typically you should check that when you compose f and f inverse, you get x. So if I want to do f of f inverse of x, that means f of x minus 3 over negative 2.5. So anywhere in my formula for f, which remember my formula for f of x was 1/2 times 4 minus 5x plus 1. Verify that. Yep. All right, so now I want to evaluate f. Instead of putting an x into the formula, I'm going to put x minus 3 over negative 2.5 into the formula for f, where all the x's are. So this is going to be 1/2 times 4 minus 5 times, instead of x, I'm going to write this whole formula, x minus 3 over negative 2.5, and then the plus 1. And now I'm going to simplify this, and hopefully I should get x. So this is 1/2. Work inside the parentheses first. 4. Now this is negative 5. And times another negative. So that's going to become a plus. And 5 over 2.5 simplifies to 2. So that's 2 times x minus 3 plus 1. 1/2 times 4 plus 2x minus 6 plus 1. Combine like terms in the parentheses. 1/2 times 2x minus 2 plus 1. 1/2 times 2x is x. Half of negative 2 is negative 1 plus 1, which is x. Now, technically, you should also do the reverse. We also should check that when you take f inverse and plug f into it, you also get x. But I'm going to leave that to you to do on your own when you're done watching this lecture.